Hello, welcome to the Center for Math's Advanced Knowledge Problem of the Week. In this week's problem, I'm going to be going over directional derivatives with a question that asks us to find the rate of change with respect to distance of a given function at point 0, 1 in the direction of another point 4, 4. So let's first write down the general form of what we're going to be needing for any directional derivative problem. So when you're finding the rate of change in some direction of a function starting at point P, what you need is the gradient vector at point P, and you're going to want to take the dot product of that with the unit vector that represents the direction it's traveling in. So let's first find the unit vector, because that will be the easiest part is going to come from the displacement vector between the 2 points, 4, 4 and 0, 1. So our displacement vector is equal to 4, 3, and then we're just going to find the unit vector of 4, 3 by dividing it by its magnitude. So we get that the unit vector is equal to 4, 3 over 5. So now we just have to take the gradient vector of the function f and then plug in point P equal to 0, 1. So the gradient vector we get is negative 6x times e to the negative x squared plus 3, and then the y component is 4 minus 2y. So now all we need to do is plug 0, 1 into here, and since the x component is going to be equal to 0, this whole term right here is going to be equal to 0, so it will come out in a nice way. So the gradient vector at point P is equal to 3, 2. So now all we have to do is take the dot product of 3, 2 with 4, 3 over 5. So when we take that dot product, we get the final answer of 18 over 5. Since there's no units given in the problem, the answer is going to be unitless. But when you're dealing with directional derivative problems, there could easily be lots of scenarios where you're going to have units, so you have to pay attention to that while you're dealing with these problems. So that concludes this week's Advanced Knowledge Problem. Make sure you check us out on Facebook and Twitter and take a look at our blog at centerformath.org. Thank you.